All right, here we go. 4.3b today. So we're going to be talking reference angles today. It's going to be all on your own notes kind of a deal. And then there is a worksheet from yesterday, or that in-classers picked up yesterday. Everybody else picked up last week. It is a 4.3b reference angle practice worksheet. It looks like this. It looks like this for those of you that.
Can you show me one more time? I didn't see it.
It says 4.3b on the top. Yeah. All right. Answers to yesterday's word problems worksheet. Those are posted on the line for your viewing pleasure. Okay. Next week, we have a summative, a 4.2 and a 4.3 summative. I should have grabbed this one on the back here still. This TAN review packet, this 3-page TAN review packet, will be collected. It's the only homework that we are collecting this unit, or this section. Okay? So, it's this TAN one that if you were in class last week, or for those of you that are all virtual, it is on It's Learning as the review packet. And then there's a link on It's Learning to turn that one in. So that one is going to be turned in. As of right now, or the schedule I should say, for the rest of this unit, is today we're going to start 4.3b. Tomorrow we're going to pick up on where we left off with 4.3b today, and we'll finish off 4.3b. And then Friday and the weekend is review. Okay, working on the review packet and anything else, getting all the questions that you need, getting prepped for the summative. Because Tuesday's class, we're going to give you two different options. Option number one is we're going to do questions and answers all day on Tuesday. Okay, so questions and answers on Tuesday is the first option. If you feel that you're ready to take the test, we can just let you take the test on Tuesday also. It is a longer test. It's 36 questions. Okay? They're not very hard questions, but the length of it, because of finding stuff with the unit circle and the trig identities and all that stuff. Okay, so there's a lot of questions on it because there's a lot of different variety of questions on it. When you take it, I would have the pink trig identities sheet with you. And actually, when you're reviewing, I'd have the trig identity sheet with you also. Okay? So that is the plan going forward. Okay. So, let's talk about an angle. Okay? So, we have angles in life. Okay? There are actually 3 distinct parts to an angle. The first part is where they meet. We call that the vertex of the angle. Okay. Then there are 2 sides to the angle. One side, and it really doesn't matter which one is which, but one side is called the initial side. The other is called the terminal side. The true definition of the measure of an angle is the amount of rotation, forgot how to spell there, from the initial side to the terminal side. That's the true definition of the measure of an angle. Okay? We've done a little bit of positive and negative angles already. Okay? A positive angle would have counterclockwise rotation. And a negative angle would have clockwise rotation. The main point today that I want to make about an angle is what is called the standard position of an angle. So the standard position of an angle has two key components. First, it has the vertex at the origin. And the point 0, 0. That's where the vertex is, okay, in standard position. The second key classification is that the initial side is on the positive x-axis. So the initial side goes straight out to the right. Okay? So if that's my coordinate system, the vertex, which was red up there before, is there. And the initial side, which was blue, is out there. Okay? So that's where it starts. And then from that, however much rotation we have to go, then that's how much rotation we have to go to get there. Okay? Remember that it's, these are in quarters, so each quadrant is 90 degrees. Okay? Good to go on that? Okay. Coterminal angles are angles with different measures same terminal side in standard position. So, for instance, if I have this angle there, okay, let's call it 45 degrees. Right? Okay? That's my angle. A coterminal angle would be (405 degrees. A coterminal angle could be negative 315 degrees. Okay? Those are all angles, when we put them in standard position, have the exact same terminal side. Do you notice a pattern between them? The next positive one would be 765 degrees. What do you got, Sean? It's just another loop around. Yeah, yep, exactly. You've already done these. Okay? You did these in the obviosities. It's just another loop around. So it's 360 degrees more or 360 degrees less. Yep, exactly. If we were dealing in radians, it would be 2 pi more or 2 pi less. Okay? It's that whole plus or minus 2 pi plus or minus 4 pi. Everything stays the same kind of a deal. Okay? So yeah, so that's a coterminal angle. So what I would like you to do now is I would like you in here and out there, I would like you to find and draw a positive and negative angle that are coterminal with the given angle. So before we do that, let's actually set where these original angles are. Okay? So I will put those in green. So negative 150 degrees, so if this is 0 degrees right there, negative would be clockwise. So I'm going to go there. So I'm down to 90. I got 60 more to go. So negative 150 would be right in that general area right there. Agree? Okay. 2 pi over 3, here is 0. Positive direction is that way. Here is pi, which is really 3 pi over 3. So I am kind of up there as my 2 pi over 3. Okay? So now you find me coterminal angles, one positive and one negative with that. For negative 150 degrees, what's a positive coterminal angle? Anybody? 210 degrees. Anybody come up with another positive? So you got? What about 570? 930. Okay, that's the next three. What's a negative coterminal angle? That's what you come up with. Negative 510? Yep. Negative 510 degrees. Like it. I also had negative 870 and negative 1230 degrees. All of those are coterminal with those. Okay. Positive coterminal angle with 2 pi over 3. What you got, Sean? Radian form. 4 pi over 3? Positive or negative? Negative 4 pi over 3 I would like. Give me another one. Those of you at home, give me one. Unmute yourself. Radian is actually easier. Because what's 2 pi in over 3? What am I really adding each time? Or subtracting each time? 6 pi over 3. Yep. So I just have to add 6 to the 2. Subtract 6 from the 2. Mm-hmm. Yep. Hmm? If you're in the over 3s, if you're in the over 6s, then it would be 12. If you're in the over 4s, it'd be 8. If you're in the over 7s, it would be 14. It's because it's 2 pi. Just like we were adding 360 degrees with degrees, you're adding 2 pi. So you got to have that fraction equal to 2 pi. Okay? All right, let's do some maths. Yeah, buddy. Find theta if the terminal side of theta goes through the point -3, comma, -2. Well, -3, -2 is down here. So there is my terminal side. Okay. So theta would be in the positive direction. That would be theta. Agree with that? Because we start out at 0 and we work all the way around in the positive direction. Okay? Well, let's break that out. So this looks like a triangle. It looks like that, right? If I were to draw that in there. This side would be -2. This side would be -3. There would be my right angle. And I'd want to find that angle right in there, correct? How am I going to find that? Tangent, yep. So the tangent of my dot angle is going to be the opposite side over the adjacent side. I'm finding an angle, so that means I'm going to be using my inverse. And what do we get as the inverse tangent of 2/3? That one? Yeah. Huh? Is that my theta? Why not? Because this is an acute angle, right? And we found an acute angle. We didn't find the whole angle, okay? So what we actually found was we found the reference angle, okay, is what we found. And the reference angle is going to be a little confusing for you, but I'm going to hopefully make it less confusing. Okay? So the reference angle we call theta prime. Theta prime is the acute angle, so that means it's between 0 and 90 degrees, formed by the terminal side of theta and the horizontal axes. Okay? Theta prime is always going to be off the horizontal, no matter where it is. It's not the closest axes. It's always off the horizontal axes. Okay? So, if I am in quadrant number 1, there's my terminal side. So here would be theta. Theta would equal theta prime, because it comes off the horizontal. So in quadrant 1, the angle is its own reference angle. In quadrant 2, there's my theta. Here is my theta prime. Theta. There is my theta prime. Okay. So the actual angle theta is going to be 180 degrees minus my reference angle. Or if we're dealing in radians, it would be pi minus my reference angle. If I'm in quadrant 3, Well, I'm sorry, I gotta go up a little higher. I'm in quadrant 3. Even if I'm way down there, okay? Theta, I'm going tight with theta. Theta is there. My reference angle, theta prime, is there, off the horizontal. Okay? Even if this angle were 269 degrees, okay, my reference angle would still come off the horizontal, even though it's only 1 degree more to get to the vertical. Okay? So here in quadrant number 3, theta is going to be 180 degrees plus my reference angle, or it's going to be pi plus my reference angle. Lastly, we have quadrant 4. So now there's my angle. Theta would come all the way around to there. Theta prime would be right there. So my actual angle theta would be 360 degrees minus my reference angle, or 2 pi minus my reference angle. Yes, ma'am.
And for the 2 pi, you'd obviously have to change the angle to radians, right?
If it says find it in radians, if your original angle is in radians, then you'd use those. If it's in degrees, then stick to degrees.
Oh.
Yep. Okay? Always comes off the horizontal. Okay? So, let's find some. Okay? So, we want to find the reference angle. I'll do the first one, then I want you guys to do the second one. I didn't do it again. Well, suddenly I just lost my... randomly stopped at 28 minutes. Okay. So the first one has 125 degree angle. Okay. So this is 0. This is 90. So 125 would be there. Ish. Right? So my reference angle would be what's left over, this part, because it comes off of the horizontal. So my reference angle would be how much? 55?
Yep.
Okay. You now find me the reference angles for the others. $210 would be, or 220, excuse me. would be down here. So my reference angle, that would be the blue. So I get 40 degrees. Yes? Okay, because it's got to get me back to 180. $310. Be down here. Reference angle would be here. Got to get back to 360. So my reference angle would be 50 degrees. Yes? Yeah. Okay. Now, let's look at the sine values and the sine of theta and the sine of theta prime. So on a calculator, what is the sine of 125 degrees? What do you got? Sine of 125 degrees. What do you got, Stella? 0.819152044? Okay. What's the sine then of 55 degrees? The exact same thing, right? Okay. So the sines are the same. What about cosine? Cosine of 125 compared to cosine of 55. So they're opposites. What about tangent? Opposites again. Okay. Let's see if that holds over here in the next one. Sine of 220. Sine of 40. You do the angle, I'll do theta prime. How does that sound? Okay, ready? So you got sine of 220 up there. I got the sine of 40 is 0.64278761. Same thing but opposite. Okay. Okay, you do cosine of 220, I'll do cosine of 40. I got 0.766044443. Opposites. You do tangent. I'll do tangent of 40. I got 0.839099631. Same. Okay. $310. I got 50. 0.766044443. Opposites. cosine. 0.64278761. Same. Tangent. Whatever it is, yours is going to be negative and mine's going to be positive. Okay? Know why? In quadrant 1, everything's positive, right? Okay? So in quadrant 2, sine would be the same because sine is positive in quadrant 2. So sine's the same, the other two would be opposites. In quadrant 3, tangent's the same, or tangent's positive. The other two would be opposites. In quadrant 4, cosine is positive, the other two would be opposites. Okay? So that's why that happens. Okay? Let's try this one. If theta is in standard position with the terminal side of theta through the point, we want to find the sine, the cosine, the tangent, and the angle. Okay? Well, first off, let's draw ourselves a picture depicting where this point actually is. Which quadrant is this point in? Quadrant 2? Yep. Okay. So that would be 5 over and 12 up would put me right there. So this angle here is theta. This angle here is theta prime. Okay. If I break out that triangle, this side is 5, this side is 12. My theta prime would be here. What's the hypotenuse? Right? Okay. So the tangent of theta prime is going to be the opposite side, 12, over the hypotenuse, 5. Right? So theta prime is going to be the inverse tangent of 12/5. Inverse tangent, so second tangent of 12 divided by 5 gets me 67.380133505 according to my calculator. Right? So since theta is in quadrant 2, right? Theta is going to equal 180 degrees minus my reference angle. So 180 minus my reference angle gives me that theta is 112.6 199 degrees. So that's my theta. I'm in quadrant 2, so I went too far now. I'm in quadrant 2, so the sine of theta would be my opposite side, which would be 12, over my hypotenuse, which would be 13. My cosine would be, my adjacent side was negative 5. Oops, I put over 12. That should be over 13. And my tangent would be negative 12 over 5. Really, it's 12 over negative 5, but I like my negatives on top. Why? Because tangent's negative in quadrant 2. Because it's 12, right? My opposite side is 12 over my adjacent side. This is really negative 5, and this is really 12 here. With me? And there's my answer. Now, we are running short on time, so I'm going to skip an example. I'm going to go right to the in general, because this is important for everybody to write down. Okay? So, in general, if theta is through a point, x comma y, and r is the radius of that circle, or the distance, that hypotenuse of that triangle, okay, then the sine of theta is going to be y over r. If we go back here for a second, the sine of theta was y. Here's my y value. Here is my r value. Okay? So it's y over r. Cosine would be x over r. Add x. Tangent is y over x. Cosecant would be r over y. Secant would be r over x, just reciprocals. Cotangent, x over y. And theta, the easiest way to find theta is the inverse tangent of y over x. Because you have those, you don't have to figure those out to anything. But there's one kicker. You got to drop any negatives. So in that last one, x was negative 5. In the inverse tangent, we would make it positive 5. Okay? We drop negatives when we use that. Okay? Whew! That's a lot to get through today. We were a little overzealous on our what we thought we would get to and how quickly we'd go through it. So that was a long day. Okay? So again, I remind you that there is a reference angles practice worksheet that you have, or it's online. It's on It's Learning. And the review packet we will be collecting, and it will be due on November 30th. Okay? Thanks for playing along.